Hello and welcome to another training video on Scuba Continuous Intelligence. In this video, I'm going to be discussing actor properties. If you haven't watched our videos about the data tab or event properties, please go back and watch those as a prerequisite to this video so that you can better understand what I'll be covering. So I'm first going to discuss what actor properties are and show examples of how we think about it in our data set and our data model. But at a high level, an actor property is a segment of users. And so a segment of users differs from a cohort, and many of you have probably heard those words thrown around, because a cohort is a strict definition of users and certain characteristics about them, and a cohort is always associated to a period of time, right? So people who graduated high school in 2021, for example, or users that have searched or purchased or done something in the last week or month or year. So with actor properties or segments of users in Scuba, you can define them in a much more loose way, meaning that it does not need to have a time definition, or it can have a time definition, meaning users who have ever purchased or users who have purchased in the last week, month, or so on and so forth. Both are a segment, but only one is a cohort. In our case, we're just considering actor properties, and actor properties are segments. So you can have a time component or you don't have to have a time component. So looking at the data, there are two main components of our data sets, meaning that there is a required timestamp and a required ID column. In this case, it's a user ID, but it can also be a machine ID or a business or enterprise ID or something like that. And so each row at the row level is an event performed by a user, in this case, or a machine, at a certain time or a certain period of time. And row after row is a successive series of either that user or a multitude of users' events that constitutes the full data set that lives behind the scenes in Scuba. So if I were to pull out a single row of data here, I can see that at April 1st, 2021, at this timestamp, user A performed a search action, and they're from US and Canada on an Android device, and so on and so forth. And so an actor property allows us to create a static or persistent definition inside of the UI where you can aggregate or collect a group of users as a definition based upon certain characteristics, like users who had their first event or signed up in a certain time period, or users who have performed a search, or maybe users who have purchased 10 or more items ever, or users who have downloaded the newest version of our software, in the first day of it being released, right? All of these are relative to specific users or people, or even machines, like I had said earlier, that are doing certain actions or meet certain criteria. And we can use that definition to then do all sorts of analysis or analytics around them. So I'm going to jump into the UI really quick, and what you'll see here is that we're at the actual actor property tab, and this is in the data tab or the data feature, data dictionary feature in Scuba. So similar to event properties, when you click on actor properties, you'll notice in the top right corner there is this button here where you can define a new actor property. Now, if your cluster is brand new, meaning that you had just become a customer and we just loaded your data set on there, there won't be any default actor properties right out of the box. Everything listed here is something that was defined and created by a user. So when you click this button in the top right, it's very similar to the process that we went about building some event properties in the previous video. So some of the differences, however, are that unlike event properties, every actor property is in context of an actor, and again, that can be anything, a user, a machine that's performing events, so on and so forth. And you also have a time option ability. So meaning that whatever it is that you're defining, you can also relate to a period of time. So you can have users who purchased as a segment or actor property, or you can have users who purchased in the last trailing 1 day or last trailing 2 weeks or at a specific static range of time. So similar to event properties though, you'll notice that there's this method. And so like event properties, there's both filter, calculate, and label, but we also have show here, similar to when you define a metric or a measure in the Explore feature. You can do things like show a count of events, or give me the first time a user has a purchase event, or you can say something like, what is the average time that it takes for something? And so I'm going to walk through some examples here. So our first example here is this actor property that I labeled number of purchases. And what we're doing is looking at our actors who are user. And in this case, I'm using the show method to show a count of events, filter to action that matches purchase confirmed. And this is looking for users that had a purchase confirmed event since the beginning of time to now. So if I look over to the right screen over here and look at what this bar chart is showing me, you'll see that in this bar, for example, I have a value of 1 and then the number of 14,244. So what is that saying? Well, in my definition, I want to show a count of events that match purchase confirmed by the number of users. So in this case, you'll see that we have a count of unique values of user. And so in this case, there's 14,244 users that had one purchase confirmed event ever since the beginning of time to now. So let's say, for example, I am a customer of Amazon and I have only gone on Amazon and purchased one thing one time ever. I would fall into this category of users. And so over here, you'll see, for example, there's 8,740 users who have purchase confirmed events happen 10 times ever, meaning from the beginning of time to now. So if you take a look at the data set, that user will have at the row level only 10 rows where they have a purchase, or in that case it was purchase confirmed event, right? And so in this case we have user A. You'll notice that user A has no purchase confirmed events, user B does, and user C does, right? So these two users, let's say that those are the only times that they'd ever purchase, they would be two unique users that had one purchase event, whereas user A and D here wouldn't fit into that category. So user A and D would be in this 0 bucket. So they would be one of the 13,316 users that had 0 purchase confirmed events. So moving on to another example here. Again, we're using the show method. And in this case, we're saying first day number. So what is a first day number? Well, in your data set, there is a point in time when there is the first row, the earliest timestamp, and that data could also be streaming, meaning right now you're collecting events and that data set is moving out on into the future. Well, every single user has to have a period in time where they have their very first timestamp. And so you can use that to create a definition. In this case, I'm saying show me the first of day number. And in this case, day number was an event property that we showed in the event properties training video. And so what we're doing is saying show me the first day that a user was present in our data set. And so what can this be used for, or why are we doing that? Well, in the data at the row level, there's a whole bunch of different timestamps, right? And so instead of taking those timestamps and manually making buckets of the individual rows of timestamp, we're saying just take each day and give it a number. And then we're saying now give me users first day number from the beginning of time to now. So if I just take a look at this, what we have over here is 26,452 users that had a day with the number of 18,372. And so where did we get 18,372? Well, the system looks back to January 1st, 1970, and we break everything down into milliseconds. And so this day that I'm highlighted over is the literal day 18,372 since January 1st, 1970. So there were 26,452 users that had their first day or first event on that day. And then here you'll see 18,373 and so on and so forth. So what I can do with this is say, well, if today is day 19,000, for example, and this user had their first event on 18,372, what's the difference? How many days has it been since that user's first day? Right? And then I can see, what other days do they come back? How frequently do these users come back? And that's more of a retention use case, which there's a separate video where we break all this down. But so again, this is a show method where we're saying, show me the first day number for every user from the beginning of time to now. So moving to another example, we have now a days active in last 7. Again, we're using the show method, where we're saying give me users or show me users, and I want to show a count unique values of day of the week. So in this event property, we're saying, let me pull that up. We are saying give me each individual day of the week, so Sunday, Monday, Tuesday, Wednesday, Thursday, etc. And if I look back at this example, it's saying count the unique values of day of week and look over a trailing 1 week window. So it's always going to be looking 7 days into the past. And so now what we have is on the legend here, we have day 1 through 7. So, Sunday to Monday. And what it's going to show you on this line, we're seeing that there are 45,464 unique users that had 2 unique values of day, meaning that they were active on 2 separate days in the most recent 7-day trailing window. And then in this case, you have the same thing, but for users that were present 3 days of the week and then 4 days and so on and so forth. And so here, now we have what we're using as a label method. So the label method, similar to event properties, allow you to take existing actor properties and then create high-level groups or rolled up aggregations based upon a value definition. So if I go back to that number of purchases query, here we're looking at the number of purchases. So we took users and we put them in buckets based upon the number of times they had a purchase confirmed event ever in our whole entire data set. And so what we can do is now nest this actor property into a label property. It's an actor property, but using the label method. And we're saying, give me users. And now I'm defining a value where, in this case, we're saying high purchasers, right? So purchasers that have a value or a number of purchases that's greater than or equal to 16. And this should be edited to 16. And so here we have users that had greater than 16 purchases, meaning that if I go back to this example, their value, and let's see if we could find it here, is 16. And I can't find it, but in this case, we have users that have this value of 17, right? Where here's that 16. So it's any user that had a value of 16 or more will be counted in this group of high purchasers. And then here we have a similar set of logic, but it's for medium purchasers. So number of purchases that's less than 16, a number of purchases that's greater than or equal to 10. And then down here, you'll see that we defined this low purchases. So if not one of the above 2 values, high or medium, then assign the value of low. So if we look at the output over here, you'll see that we have 70,000 users that that fit into the low category, meaning that they had less than 5 purchases, and then respectively for our medium and high purchasers as well. So moving forward, we have now another label property, or we're using an actor property with the label method, where we're saying, did users purchase ever? So again, we're taking that number of purchases actor property and we're nesting it into a new actor property. And we're saying provide the value of yes if they just have a value greater than 0 for a number of purchases. Meaning that if you have 1 or even up to 100, that means yes, you have ever purchased. And so assign them the value of yes. Whereas if the value matches 0, meaning they had never had a purchase event, then that is a value of no. And so you'll see here that the users fit into those respective categories. Users that did purchase and users that have never purchased. And so moving to another example, we have a filter method. It's another actor property. And in this case, I'm not setting time dimension or a time related criteria. I'm just saying, give me users who have ever purchased. And so this is just a count of users who purchase. And this kind of filter can just be applied. Let's say you have a very, very large set of things or action types that meet the criteria for an engaged user. It might be like 100 different types of events. Well, you can create a filter of those different events as something like engaged users, or in this case, it's just one action type of users that purchase, but you can save that, and then it's very easy to apply those users or those filters to existing measures when you're building an Explore query. And so lastly, I'm showing now a calculate method. So calculates are much less commonly used, but in this case, I'm getting the number of days active in the most recent or last 7 days and the number of days active in 14 to 7 days ago and subtracting the difference between each other. In this case, you might want to see something like the number of days that users had in those two different time periods. There's a lot of different examples that you can kind of think of or use for the calculate method. But in general, it follows the same format as our function and our calculation video, if you go back and watch those. But when you press the equal sign, you are able to then either select from existing functions or open a square bracket and then choose from the existing actor property definitions and only actor property definitions to create a calculate nested actor property. And in this case, we had days active in last 7, and we were subtracting the days active in 14 to 7. So that's a calculate example there. And now I'm going to show a query in the UI that actually ties these actor properties together. So here I have two different measures. This is users who did purchase ever and users who have never purchased. So what did we do? I said, give me a count of unique user actors, and I'm filtering it to the did purchase ever actor property, which I think was, let's see, back here. So we're using the label property to create a yes and a no category for users that did or did not purchase. And so in this, it's saying, give me the users where the value matches yes, because they have greater than one purchase, and give me the users that did not purchase, so they have a value of no. And then what I'm doing is saying, give me now the number of purchases, which was that first actor property that we created. And I'm saying, now show me the number of purchases that these users had. And so the results here are showing in the left column in this table is number of purchases. So the output from here is just the numeric number of purchases. And then in this second column, users who did purchase ever, it's giving me a count of users that met this criteria of yes, and it's showing which bucket that they fall into, right? So if I go back to the number of purchases, you'll see similarly here, users that had 3 purchases, there's 9,000 of them. So in this case, because we're looking over a different time window, you'll see the different number of users that had purchases. And then respectively, in the second measure, users who never purchased, we're getting a count of user actors that did not purchase. So in this case, we have 0 users who actually purchased. So in this case, they do not meet the number of 1. They are actually 0 and always 0. So there will never be a user that meets one of these criteria if they are in this bucket. So if you have any other questions or are interested in learning more about other features in the product, please watch the rest of our videos or reach out to help@scuba.io. Thanks.